Class?
Yes.
All right, thank you. I am glad you all are here. Some people are near for the first time this semester. Don't ditch my class again. All right, so we're going to write cosine x in terms of tangent. Okay, cosine x in terms of tangent. So we're going to use some of those identities that I gave you on that, what's it, slide 3? Slide 3. Slide 3? Yes, slide 3. So I want to have tangent somewhere in my identity I'm going to use. So I'm going to back up to see which one I want to use. Right here. So which one of these has tangent in it?
The tangent one?
Yeah, the tangent one, right? Yeah. So that's the one we're going to use. And you'll see why in a moment, okay? We want to write this, and I want to use this. So in terms of tangent, so I wanted to say tangent is equal to. So I want to have tangent in my equation here. So let's see. I'm going to write this out. So it's tangent squared theta plus 1 is equal to, there we go. Now the thing I was trying to teach you about on Monday, what are we doing with this information? This is kind of difficult here, right? What do we want to try and do with this information here to make it easier? I want to translate it, right? Let's translate it into algebra. If we translate this into algebra, tangent is y over x, right? Yes?
Yeah.
So this is going to be y squared over x squared plus 1 is equal to secant. Secant is supposed to be r over x, right? But if this is an identity, what is my r always going to be?
1.
1. All identities, r is 1. All identities, r is 1. So this is going to be 1 over secant squared, which is x squared. Okay? Now, using this information right here, I'm going to go off to the side to show you if my identities r is 1, if on all my identities r is 1, cosine is always x over r, but r is going to be 1. So technically I could say cosine theta is just x, isn't it? Because it would be x over 1, which is just x. So this is what we're doing right here. We're trying to get this x squared here by itself. So I wanted to say x equals, so this right here, this is what this means. I wanted to say x equals, and so I'm going to rearrange this to make it say just x equals. And I want to leave tangent. So wherever I have tangent, which is y squared over x squared, I want to leave that there. I want to leave y squared over x squared. So we're going to do some manipulation with my math. But first, I have an x squared. This is my x squared that I want to get. This is my x squared that I want to get. I want to get it out of the bottom. Mathematically, what would I do to get this x squared out of the bottom there?
Multiply.
I'm going to multiply because if it's on the bottom, it's dividing, right? So I'm going to multiply both sides by x squared.
Wait, I have a question, Patrick.
Yes.
Why should we not the data with the 1 over x squared?
Say what?
The data you need to bring it down.
You're right. Because it's no longer theta. We're just translating our trig, which is this, into algebra. Our algebra doesn't have the thetas. Does that make sense or no? So we change this into these. This is trig language. This is algebra language. So we're multiplying both sides by x squared. Yes? Okay. So what's going to happen to the x squared on the right-hand side? It's canceled. That's good. So we're left with 1 is equal to x squared quantity y squared over x squared plus 1. Yes?
Wouldn't those cancel too?
What cancel to? I could, but the problem is I want my answer to say tangent. Because if I do, okay, I'll show you what's going to happen here, okay? But then I'm going to back up on this. She's saying it will cancel because it will. If I distribute here, my x squareds will cancel, and I would be left with just y squared. Very good. And over here, as I distribute here, I want x squared times 1 is x squared, right? Yes? And that would mean that I'm left with equal to 1. So, does this still say tangent here? What is tangent supposed to say? Y squared over x squared, or at least just y over x, right? So since I want it to be tangent, which is, another color, y over x, I don't want to distribute that. That's the only reason why I'm not doing it. Normally, algebra, I would do that. But in this case, because it's over here, I want to still have this say tangent. That's why I'm not distributing it. Make no sense? Little sense? No? Don't do it. Watch. It might make a little sense when I.
Wait, so we don't do that?
No, because I wanted to read x squared, tangent. I wanted to read this. I wanted to say y over x. Because my answer has to be in terms of this. Is that make sense or nonsense?
So why'd you write it? Yeah, I wrote in pen.
I wrote it because she was asking what's gonna, why don't I do that? I canceled out that. Okay, yes, don't do that then. I was trying to say don't do that. That's why you don't do that. Because my answer has to say tangent. So we're just trying to isolate to get this by itself. Now, what am I going to do with this? What is happening to my x squared that I'm trying to get by itself over here? What is happening to this in between this and all of that? It's multiplying, right? Say yes. That's multiplying. This is a multiplication right here. But I don't want all of this over here. If this is multiplication, how I undo the multiplication? Divide. But I want the x over here, but that means I need to get rid of everything else. So I'm going to divide both sides by everything else. Because that's a multiplication. So I'm going to divide both sides here by y squared over x squared plus 1. All that's in parentheses. And do the same thing over here. Yes? No? Maybe. Because what's happening over here, this and this will cancel. Right? Yes? Are you guys okay or no? No. Okay, tell me why no.
So, why did you divide?
I divided because I want to get, this says right cosine in terms of tangent. So, using this identity here. Hello.
Hey, how you doing? Excuse me.
Give me 1 second, let me.
Just because the x squared.
All right, does that make sense now, or? Yeah, thank you for the clarification. So we're trying to get this by itself. So I moved it out of the bottom first, and by multiplying it, and then now it's on this side, it's now no longer in the bottom of my fraction. So I divided by this to get rid of these. So now as I rewrite my problem, I get x squared is equal to 1 over, this is y squared over x squared plus 1. Yes, no, maybe? Yes? No? So, you don't like that or no? Are you okay with the canceling this out? Are you okay with x squared multiplying by both sides? Okay, are you right here with, because it's a multiplication, to undo that, because that's the piece I have to get rid of. Because I'm trying to get my x squared by itself, right? Trying to get the x squared by itself right here, so I'm multiplying, and to undo the multiplication, I have to divide to get rid of that. So think about it. What's the piece that you don't like?
No, I get it.
Oh, okay.
Is that a 1 on top of here?
Yes, that is a 1. Because there was a 1 right here when I divided this out, right? There was a 1 on top. That 1's still staying there. Now, I have x squared. I don't want x squared. How do I undo a square? Square root. So I'm going to square root both sides. So let's see. Do I have another page over here? Yes, I do. Okay, I do have another page, so I'm going to go to that one because I don't want my work to be messy. Now, we're going to square root both sides, but when I square root, what can I not forget? Plus or minus. Every single time we got to remember plus or minus whenever I'm square rooting. So it's going to be x is equal to plus or minus square root of 1 over y squared over x squared plus 1. I know it's weird, but that's what the answer is.
That's the whole answer.
That's the answer, but that's the answer in what translation? In algebra. So when I'm done here, which I am, what do I need to do? What's going to be my next step?
Replace the y over x with cosine?
No. What is y over x?
Tan?
Tangent. So this is in algebra. We translate it back to trigonometry. So back in trigonometry, this says that x by itself, we said x by itself should be just cosine, right? Yes? Cosine theta or cosine x. I like using theta because we're using x as a variable. Plus or minus 1 over y squared over x squared is going to give me tangent squared plus 1. All right. Questions, concerns, complaints? Conspiracy theories.
Wait, is it plus or minus? What is it?
It's always plus or minus
Is it
because,
both?
yes, it is both because we don't have anything here saying that, if it said that this has to be in quadrant 1, tangent is positive. Yes?
So once you're done solving like the whole equation, since you have the y squared over the x squared, we would just put it back in the time.
Yes, you just translate it back into trig. So the reason why we're doing all this is because the algebra is a lot easier than using all the trig identities together. It is so much easier than having to remember, let me see, I think there comes out to be 9 identities. I stopped using identities so long ago that it just X, Y, and R for everything. You don't have to know all the identities that go along with it. All right. Anyone else? Questions? No? Okay, let's just keep going. We'll go from there. So I'm going to do example 3 also because that's part of what we're doing. All right, this problem right here says write this in terms of sine and cosine, then simplify to expression where no quotients appear. What is a quotient? Division. Yeah, no division. So what we're going to do is this is going to translate into 1 plus, what is cotangent?
X over Y.
X over y. So if it's cotangent squared, that is going to be x squared over y squared divided by 1 minus cosecant. What is cosecant supposed to be? 1 over y, right? 1 over y. So cosecant squared is 1 over y squared. 1 over y squared. Okay, are you guys okay with this for this translation or no? We're just replacing each item in trigonometry with whatever it would be in x, y, and r, but in these cases r is always 1. Yes? Maybe? As long as we're not Googling it. Yeah, I see you there. Now, I don't know if you guys actually learned how to do these problems in whatever Algebra 3-4 class or for Algebra 1 class you had. This is actually supposed to be in Algebra 1. So, if I was your Algebra 1 teacher, probably wasn't even covered anyway. We keep changing curriculums like every other year, so you guys probably miss out on a bunch of these. So I'm not going to imply that everyone knows how to do this. We have fraction over fraction here, right? And since we have 2 terms on the top and 2 terms on the bottom, what we could do, we can get rid of all the complicated fraction by multiplying by the common denominator of everything. So common denominator is, I look at each denominator, and common would mean together, right? Same thing. But in this case right here, the common is just y squared. But if this one was y squared and this one was x squared, the common denominator would be x squared y squared. It would be both together. But in this case, my denominator, this denominator is 1, this denominator is y squared. This denominator here is 1, this denominator is y squared. We're going to multiply top and bottom by y squared. So watch this. So what I'm technically doing is, I'm multiplying by the value of 1. Because y squared divided by y squared is 1. And if I multiply something by 1, I get the same thing. But it's just going to look different. That's all I'm doing. I'm changing the way this looks. Now by doing this, I'm going to distribute. So y squared times 1 is y squared. And y squared times x squared over y squared, what's going to happen right there?
2x squared. No, y squared.
What's going to happen? Am I multiplying by y squared and dividing by y squared? I have a y squared on top and on bottom. So if I'm multiplying, that means it's going to be on top. So it's multiplying is on top, dividing is on bottom, and so the y squareds will cancel.
So just x squared.
So it's just x squared. So now I have uncomplicated the numerator. I have uncomplicated the numerator, right? Yes? Maybe? Yeah? Good. Now let's do the same thing in the bottom. So if I do the same thing on bottom, I get 1 times y squared is just y squared, positive y squared, right? And when I distribute here, what's going to happen right there?
Cancel the 1.
It's going to cancel out, right? The y squareds will cancel because I'm multiplying by a y squared, and I also have a y squared on the bottom. So those are going to be canceling out. So that means what it's going to be left? Just 1. So it's going to become minus 1. Now, do me a favor. I want you guys to go look at slide number 3. Slide number 3 tells me that this first thing on top is going to give me a different answer. Whenever I see x squared plus y squared, that's going to give me a different answer. What's that going to give me in trigonometry? Slide 3. 1, right? So x squared plus y squared is 1. That's what the Pythagorean identity is. So whenever I'm doing these problems and I have x squared plus y squared, that's always just going to give me 1. So whenever I have those together, I could eliminate that whole part of the problem by replacing x squared with x squared y squared with just 1, like that. Now, on the bottom, it's going to be slightly different. Slightly different. Okay, as long as you're paying attention and not trying to sleep right now. I know I'm just that boring. I'm sorry. But we're going to get this one here. So I'm going to use that same identity we just had. X squared plus y squared equals 1, right? That's the same identity. And I want to do something interesting here. So I got to rearrange this because what's on the bottom of my previous one says y squared minus 1. Can I turn this or do some finagling to make this into y squared minus 1?
Yeah.
I can. So what would I do with my 1? Right here it's positive, isn't it? Say yes. It is positive, isn't it? So what I'm going to do is I'm going to subtract 1 from both sides. So I have x squared plus y squared minus 1 equals 0. And this is going to be the basis on some of the other identities you're going to get. Like I said, I don't teach the identities, I teach the algebra on how to get it, because there's so many different identities. You could just do the math to actually get each one that you need. A lot of times, you have to make an identity for something that you need, just for substitution. So now we're over here. What am I going to do? Because I only want to have this right here. What am I going to do there? I still have an x squared here, right? Subtract x squared, right? So if I subtract x squared from both sides, I have y squared minus 1 equals negative x squared. So what I'm trying to do is replace this. So that's also another one of those identities. So when you see that you have y squared minus 1, what can you replace that with? What can you replace y squared minus 1 with?
Negative x squared.
Negative x squared. So this pops up so often, that's why I'm telling you this comes up here. Or if it would have been x squared minus 1 would be equal to negative y squared. So this is the basis of what we use a lot of this for. So I'm going to replace my y squared minus 1 with negative x squared. All right.
Wait. Show me about that again. This is the last part.
All right. Are you okay here? Y squared minus 1 equals negative x squared.
Yeah.
Okay, so right here, because I subtracted x squared from both sides, we came up with this, right? And so every place where you see y squared minus 1, you could replace that with negative x squared. Just like we replaced x squared plus y squared with 1.
Oh, okay.
So these are identities that we're using to simplify to get rid of a lot of this.
Okay. Thank you.
Okay, now I'm going to go back and have this. So now my answer is complete. My answer is complete, and it's in trigonometry here, right? In algebra, so I have to translate it back to trigonometry, and I want my answers only to say sine and cosine. So 1 over x should be secant, but I don't want it to say secant. I only could use the answers as cosine or sine. So I could write my answer here as 1 over, what does x represent? What did you say x by itself?
Sine. What's that?
Cosine. It's just cosine. X by itself is cosine, so negative cosine squared theta. Yes, no, maybe. Conspiracy theories. Crazy stuff. Maybe, no. I think these are all, that's all the examples that we have, but I'm trying to go super slow so everyone has time to actually answer or ask any of the questions that they want.
I get what you're doing, but I don't understand.
You don't understand why?
Me either. Me either.
Like, it's just a lot.
Oh, yeah. I agree. That's the reason why this section, I came out at the very beginning, honest. This is actually the hardest one out of the entire course. And that's why I'm taking time, each item by item, going over each one. So today we're going to actually use the rest of this class to go over the homework problems. And hopefully we could do some of these together. Hopefully. If we're doing that and not just playing on our phone again.
Me?
Yes, you with your phone out.
Again?
All right. Hey, don't forget, like, share, subscribe. Hit that notification. Buy stuff from my merch store. Links in the description. All right. Bye now.